Okay, so today we're going to look at still solving quadratics by factoring, but when we end up having terms on both sides and how we handle that. So, looking at that first example problem there, what happens when you are presented with a problem that asks you to solve but doesn't equal 0? So, we want to think about a problem that looks like this. So, how would I solve this problem? The issue is things are on both sides of the equal sign, and I don't want that. So what we're going to learn today is getting this thing equal to 0 first, and then we're going to go through and do what we did in the last video, factor everything and then set everything equal to 0. So if the quadratic equation doesn't equal 0, first thing we want to do is use inverse operations to equal it to 0. Now, another issue that we run into is figuring out which side we want to move things to. So we always want to move everything to the side that makes the squared term, so the x squared, positive. Okay, so we always want that thing to be positive. So when I look at the problem up here at the top, I see that the x squared is positive on the left side. There's no other x squareds on the right side that I would have to subtract to potentially make it negative, moving things to the left. So what I would want to do is use those inverse operations to move the positive 2x and the positive 12. So what that would look like, to move the positive 2x using inverse operations, inverse meaning the opposite, I would subtract the 2x over. Okay, I would subtract it to both sides, because 2x minus 2x cancels out and gives me 0. Likewise, with the positive 12, I would subtract the 12 from both sides, and again, positive 12 minus 12 would cancel out. So now, my new equation would look like x squared. 1x minus 2x would be negative 1x. And then there isn't a number on the left side, so I would just have this minus 12 now. And on the right side, everything canceled out, so I now have 0. All right. Now, once we have the quadratic equal to 0, I'm now going to factor using one of the methods we've learned. So if you think about all the methods of factoring we have big X. Okay, and that's when a equals 1, right? It's just x squared in the problem. Then we have AC method, and that's when a doesn't equal 1, meaning that the squared term has a number in front of it. We had grouping. That was when I had 4 terms in the problem already. We had difference of squares, right? Perfect squares with a minus sign. And then we had the sum of cubes and the difference of cubes. All right, so all of those things could possibly come up for step 2. And the final step, once I have it factored, right, so my factors would be something like x, if I think about this problem up here, right, factors of negative 12 to add up to negative 1, that would give me negative 4 and positive 3. So my factors would be x minus 4, x plus 3. So that's an example of big X, right? Then my final step would be to set each factor equal to 0. And then solve it. So for this problem, just to finish it up, I would have x minus 4 equals 0, and the x plus 3 equals 0. So adding the 4, we would have x equals 4, and subtracting the 3, we would have x equals negative 3. All right? So we're really just adding in one more step at the beginning, making sure this thing equals 0 first, and then I go through and do my factoring and setting everything equal to 0. So let's look at an example here. So I see that I have terms on both sides. So I want to figure out which side has the positive square term. So I look, I see here's my squared term, and it's already positive. There's nothing on the right side to move over to the n squared, so I'm going to move everything to the left side. So I need to move this positive 4 by subtracting it. Now I can't subtract the 4 from the negative 3n, and I can't subtract the 4 from the n squared because those aren't like terms. So on the left side, I would have to leave the n squared alone, the minus 3n alone, and now I have this minus 4 over here as well. On the right side, it all equals 0 now. Everything cancels out. So now I have a quadratic in standard form. This is what we're used to seeing. So I notice that my squared term is by itself. Okay, so by itself means I'm using big X. Alright, so setting up my big X, C goes on top, B goes on the bottom. My factors of negative 4. So I could have 1 and 4 or 2 and 2. I need it to add up to give me negative 4. So when I look, I see this 1 and 4. That's the only way I can get to 3. But I need it to equal negative 3, so that means that the 4 has to be negative. So I would have 1 and negative 4. So my two factors, n plus 1 and n minus 4. Final step, set each piece equal to 0. So n plus 1 equals 0, n minus 4 equals 0. Subtract the 1, and add the 4. And we're done. Alright, so here are 3 example problems. If you want to, go ahead and pause the video and try these on your own first, and then you can fast watch the video to make sure your steps match mine and that you get the right answer. So go ahead and pause if you want to. Alright, so again, step 1, get it equal to 0. So here is the squared term. It's already positive, so I want to move everything to the left side. So we're going to add the 15 over. So I would have n squared plus 8n plus 15. Step 2, we're going to factor. Here I see that n squared is by itself, so we're going to do big X. So setting up my big X, factors of 15 that add up to 8. So my factors of 15 are 1 and 15, 3 and 5. I see it right off the bat there. The only way to add up to get 8 is with positive 3 and positive 5. So two factors, x plus 3, x plus 5. Final step, set each piece equal to 0. So x plus 3 equals 0, and x plus 5 equals 0. Subtract the 3, subtract the 5. Alright, now for the final 2 example problems here, I'm going to go a little bit quicker. So here's the squared term. It's positive, so I want to move everything to the left side. So minus 3y and minus 28. The 3y's cancel, the 28's cancel. Nothing on the left side is like terms, so I can't combine it with anything. So I would just write all the pieces. Y squared minus 3y minus 28 equals 0. The squared term's by itself again, so I'm going to do big X. Factors of negative 28 that add up to negative 3. Factors of 28, 1 and 28, 2 and 14, 4 and 7. The only possible way to get down to negative 3 is with this 4 and 7. but I want it to be negative, so that means the bigger number has to be negative. So negative 7 and 4. So my two factors, y minus 7, y plus 4. My final step, setting each piece equal to 0. Add the 7, we get y equals 7. Subtract the 4, y equals negative 4. Alright, now the last one is the trickiest. We have to move everything to one side. And we need to first figure out which side's going to be positive. So in this problem, I have a squared term and a squared term. Now, if I subtract this 3y squared to the right, that's going to make the squared term negative. So I don't want to do that. But if I move the w squared to the left, that would leave it positive when I do my subtracting. So we're going to move everything to the left. So I'm going to subtract the w squared. I'm going to subtract the 4w. And then add the 5. Cancel, cancel, cancel. So 3w squared minus 1w squared would be 2w squared. Negative 7w minus 4w would be negative 11w. And then 10 plus 5 would be plus 15. Now, to do the factoring, I noticed that the squared term is not by itself. So we're going to have to do the AC method. So here's A, here's C. So on top, A times C is 30. Those factors need to add up to negative 11. My factors of 30, I have 1 and 30, 2 and 15, 3 and 10, 5 and 6. So the only way to get 11, that 5 and the 6, but it needs to add up to be negative 11. Ooh. I don't know where everything just went. So to get negative 11 here, I would need the 5 and the 6 to be both negative. So negative 5 and negative 6. Now remember, with AC method, that means that I'm replacing this middle guy with the two numbers I just found. So I'm going to slap some w's on both of those and place those in the middle. So the 2w squared stays. I'm changing the negative 11w to minus 5, minus 6, and then the plus 15. Do your grouping. The only factor of the first two terms would be w. Divide a w out, we would have 2w minus 5. Looking at the second two terms, I could take a 3 out, but because this guy is negative, I'm going to take out a negative 3. And that would leave us with 2w minus 5 on the inside. Remember, with factor by grouping, we always want the insides to be the exact same. If they're not, that means you made a mistake. Alright, so let's write our two factors. We have w minus 3 from the outside, and then the inside is 2w minus 5. Setting them equal to 0. Add the 3, we would get w equals 3. Add the 5, you'd have 2w equals 5, and then dividing by 2. This one would be a fraction. And always leave it as the fraction, 5 over 2. Alright, so let's keep going. Here are some more example problems for you to try if you want to. I'm going to do them really quickly. But if you want to pause to try them first, go for it. So, both of them are negative. To make it positive, I would have to move the bigger one to the other side to make it positive. So I would add the 5k squared. And then subtract the 6. So k squared minus 8k minus 9 equals 0. Big X. My factors of negative 9 that would add up to negative 8 would be negative 9 and 1. So k minus 9, k plus 1, setting them equal to 0. Add the 9, subtract the 1. And we're done. Alright, b squared's positive, so we need to move to the left. So b squared, that's a b, not a 36, plus 2b minus 35 equals 0. Factors of negative 35 that add up to 2. We would have 7 and 5. Positive, though, so the bigger number's positive. So b plus 7, b minus 5. Setting them equal to 0. And then doing the opposites to get the b by itself. So b would equal negative 7, b would equal 5. Alright, last one here. It's already positive there, so we'll subtract the 5. Okay. Not by itself, so we have to do AC method. So 3 times negative 12 is negative 36, and it's got to add up to negative 16. So my factors of 36, 2 and 18, 3 and 12, 4 times 9, 5 doesn't work, and then we have 6 times 6. So only way I can see to get 16 is using the 2 and the 8. I need it to be negative when I add, though, so that means the bigger number is negative. Slap some r's on those guys, and then I want to replace the middle. So 3r squared minus 18r plus 2r minus 12. Do your grouping. Alright, the GCF of the first two terms would be 3r. Divide. So that would leave me with r minus 6. The GCF of the second two terms would be positive 2. Divide. I would have r minus 6 again. So my two factors, the outsides, 3r plus 2, and the insides, r minus 6. Setting them equal to 0. Subtract the 2 and divide by 3. That would leave me with r equals negative 2/3. Add the 6, r equals 6. Alright, the last thing we're going to talk about real quick is what happens when there is a GCF. So, there are two cases that can happen here. If the GCF includes a variable, a letter, then we have to set that equal to 0 as well when we solve. If the GCF doesn't include a letter, so it's just a number, then we just cross it out. Alright, and I'll show you what I mean right now. So, r squared's positive. We're going to add the 7 over. So 7r squared minus 14r plus 7 equals 0. So, check for a GCF. I notice that my GCF here would be 7. Right? Everything is divisible by 7. So, putting that GCF out front, divide by 7, we would have r squared minus 2r plus 1. Now, when I think about factoring, the r squareds by itself, so I would just do big X. Factors of 1 that add up to negative 2. It would have to be negative 1 and negative 1. So we would have 7, r minus 1, r minus 1. Now, let's just go through and set each piece equal to 0 like we normally do and see what happens. So, 7 equals 0, r minus 1 equals 0, and do it again, it doesn't matter. So, handle the first two like normal. Add the 1. So we would have r equals 1 Now, you don't have to write it twice because they're the same, but if you do, it's not incorrect, right? Now, the issue here is looking at this right here. Now, it's just a number. There's no variable there. So when you look at it, it doesn't really make sense. It just says 7 equals 0. That's not true, and we can't do anything with it to make it true. So we just cross that out. Okay, that doesn't give us a solution or an answer. It just makes factoring easier. All right, so let's look at number 8. In this case, our biggest variable is this 2x to the third. So that's the thing we want to make positive. So that's a little side note you can make. We always want the highest exponent to be positive. Okay, not only do we want it to be the x squared when we're doing our normal quadratic problems, right? Anytime we have a problem we want to set it equal to 0, we just want the highest exponent to be positive. So you can apply this to any polynomial. In this case, we're looking at x to the third, so I want that to be the positive number. So I'm going to move all of this to the left. So subtract and add. So we would have 2x to the third minus 22x squared plus 60x equaling 0. So again, I want to look for a GCF. In this case, my GCF, remember for variables, you want to look for the smallest exponent. In this case, the smallest exponent is x to the first power. And then I want to look at my numbers, 2, 22, and 60. The largest number I can divide all of those by is 2. So my GCF would be the 2 and x to the first power. So GCF 2x. Go through and divide everything by 2x. So we would have x squared minus 11x plus 30. Factor like normal here. X squared's by itself, so we just do big X. So factors of 30 that add up to negative 11. For the sake of time here, I'll just tell you it is 5 and 6. But it needs to add up to negative 11, so they both have to be negative. So my 3 factors in this case, 2x, x minus 5, and x minus 6. ZHP is equal to 0. In this case, there is a variable in the GCF, so I am going to include that as part of my answers. I'm not just going to cross it out. And x minus 6 equals 0. So divide by 2. 0 divided by 2 gives me 0. That is one of the answers. It's very important you include that. Okay, don't leave that off. Add the 5 and add the 6. So this one has 3 answers. All right, last example here. Biggest exponent. So move everything to the left. So I'm going to subtract this 75w squared. So 12w to the 4th minus 75w squared. So we want to look for GCF. Smallest exponent, so the w squared. I recommend circling it, right? Look through your problem. If they all share the same letter, okay, that's going to be part of your GCF, and then you want to find the smallest exponent that goes with that letter. So in this case, it would be w squared. All right, so w squared. And 12 and 75. Those are both divisible by 3. Okay, so the largest number they're both divisible by is 3. So that goes up front. Dividing everything by 3w squared, that would leave me with 4w squared minus 25. Now I have a binomial, 2 terms, right? So I want to think, is this difference of squares, sum of cubes, or difference of cubes? Well, first off, I see a square, so it's not either of the cubes. So I want to look to see, do I have perfect squares and a minus sign? So 4, perfect square, w squared is a perfect square, and 25 is a perfect square, and I have that minus sign. So I want to do my square rooting. So square root, that leaves me with 2w and 5. So remember, difference of squares, a squared minus b squared, right? I do the square roots, and I get a and b. So I would have a plus b, a minus b, right? It follows that pattern. So for number 9, my a is 2w and my b is 5. So my two factors, so GCF, and then I would have 2w plus 5 and 2w minus 5. Setting each piece equal to 0. Don't forget that GCF, right? It has a variable in it, so we have to include that. And 2w minus 5 equals 0. So divide the 3. We would have w squared equals 0. To get rid of the square, I'm just going to square root both sides. So w would equal 0. Subtract the 5. And divide. Okay, add the 5. And divide by 2. And we're done.